Yeah, hello students. Let me introduce myself first. I am Imad Latif and I am a physics graduate from University of Peradeniya, and I did my masters in electronics from University of Colombo. I am the physics lecturer here, and we are going to discuss a part in international advanced level, that is AS level part. Unit 2 component, that is electricity. In that one also a part of that one as a example with you. So, let us discuss today's that particular part, that is in electricity, which is internal resistance. So, this is your specification. Once we come for the specification, you can go to the Edexcel website and you can download the specification, and you can see whether the same the particular specification is dragged into the presentations. So, in this one we should know what is the electromotive force and understand what is meant by the internal resistance of a battery or a power supply, and the terminal potential which is arising due to this internal resistance. Of course, we have a practical part that is normally we have to deal with it. So, the practical part normally comes in different parts in Edexcel throughout the Edexcel physics syllabus. Okay, let us come what is an internal resistance. Now, the internal resistance is usually means the electrical resistance inside the batteries and the power supply. So, you can see the image in that one. You see there is a battery, and inside the battery there is a resistance is there. Okay. So, due to the internal resistance of the battery, some energy wasted by the battery as heat. Now, you see sometimes you use the, let us say you use your charger or the batteries when you are using for a long time, you see when you are holding it, it's become little warmer. That is due to the internal resistance. Now, that is why now you can see what I have written in the presentation. Due to the internal resistance of the battery, some energy wasted by the battery as heat. That is why the battery gets heated as connected to a circuit. Let us go little further with the topic, and let us come for this one. Once we have the internal resistance, the voltage provided by the battery to the external circuit is less than what is mentioned on it. For an example, let us say you are getting a battery like a Panasonic or everyday battery, or there are so many batteries available in the market. Normally, let us say a AAA battery or a AA battery with 1.5 voltage. Now, let us say if it has an internal resistance, normally it has, if it has an internal resistance, let us say you connect it to an external circuit, then the voltage supplied to the external resistance will be less than which is marked on that particular battery. This is called the internal resistance. So, that is what I have mentioned here. You can see this circuit. I have given two circuit diagrams, one without the internal resistance, other with the internal resistance, and I have connected two voltmeters across the one without the internal resistance and with the internal resistance. So, without the internal resistance, if you have a particular circuit, let us say you connect a voltmeter, so it is going to show the voltage same as the battery's voltage. But once you have internal resistance in a battery, once you connect a voltmeter there, so the voltage provided to the external circuit will be less than which is mentioned, because it is going to kill some voltage inside it. Alright. So, this is what the internal resistance. Hope you are clear with this what is meant by the internal resistance. Now, we are going to derive the internal resistance equation. So, now you see that square dash box. In that one, that whole dash box indicates the battery. So, for our convenient, I have given the resistance outside the two the battery, because battery is indicated by the long line and the short line, but it's outside because but in reality it should be inside that one. All right. Now you have the circuit here and it's connected to an external resistor R, and I am measuring the voltage across the external resistance by connecting a voltmeter. So let us derive the equations. So let us use the Kirchhoff second law, or we call as the Kirchhoff voltage law. Sometimes they say Kirchhoff voltage law or Kirchhoff second law. Sigma is equal to sigma IR for the complete circuit. Let us use the sigma is equal to sigma IR for the complete circuit. Then you will get as, see, we have only one EMF, that is E here, equal to, let us say I mark the current in the circuit as I. So it's a sum of the IR values. You know, the Kirchhoff second law indicates the EMF provided by the battery in EMF in a complete circuit equal to sum of IRs in that circuit. So by using that equations, I have taken E is equal to, that is the only one EMF there, that value is E equal to current in the circuit is IR plus I have put I into simple R. So from these I can take the I commonly out. So E is equal to, I have taken the I commonly out of the bracket, that is R plus simple R. So we can find the current from that. So just divide, that is I equal to E over R plus simple R. So of course you can find the current from this equation, which is inside the this with the internal resistance. When you have a circuit, a battery with an internal resistance, when you connect it to an external circuit, this is the equation for the current. Also the voltage across the resistor R, let us find the voltage across the resistor R. Just use the Ohm's law, V is equal to IR. So I already you found, that is V is equal to E over R plus simple R into again R, you will get the voltage. This is the way we are doing the calculation in internal resistance, but of course there are further more calculations that you have to carry out to become stronger in this chapter.